For question 1, we're comparing the interaction force, the force that block A exerts on block B, and the force that block B exerts on block A. The interaction between those two blocks. Newton's third law tells us that when two objects interact, they interact with equal and opposite forces. So the answer here is C. The force block A exerts on block B is equal to the force block B exerts on block A. I assume we're talking about magnitudes of the forces here. If we were taking direction into account, they would be opposite in direction. So if I wrote that in vector notation, FA on B is equal to the opposite of FB on A, but we know that their magnitudes would be the same. For number 2, the boxes are still moving at constant speed, but now we're talking about the net force on block A compared to the net force on block B. And we know that if they're moving at constant speed, the net force would have to be 0 because the net force is equal to ma. When A is 0, we have no acceleration, and we get the net force is 0. So the net force on block A would have to be 0 since block A is not experiencing acceleration. And the net force on B would have to be 0 since B does not experience any acceleration. So the answer to this one is G. None of these are correct. Now we don't have 0 acceleration. The blocks are slowing down. So we do have acceleration opposite the direction of motion. Does Newton's third law still hold true? The answer is yes. When these two objects interact, if A exerts a force on B, B exerts an equal and opposite force back on A. Doesn't matter if the acceleration is 0 or non-zero. Doesn't matter if they're speeding up or slowing down or moving at constant speed. Force that A exerts on B is always equal and opposite to the force that B exerts on A. So the answer here is C. For number 4, the blocks are slowing down, and we're looking at the net force on A compared to the net force on B. So let's take a look. What do we think the net force acting on block A, what direction does that have to point if block A is moving to the right but slowing down? If block A is moving to the right but slowing down, the net force must be to the left. Block B is moving in unison with it. They're touching each other. So the net force on block B must be to the left. That helps us narrow it down a little bit. Now we have to think about the magnitude of the force. Since F equals ma, and the acceleration is the same for both blocks, the acceleration of A is equal to the acceleration of B, then the mass is going to determine which one experiences a larger force. So the net force on block A, the magnitude of the net force on block A, must be greater than the magnitude of the net force on block B. The answer would be D.